Hey, what's going on, guys? So in this video, I'm going to be solving trig equations using identities. The past two lessons, we've been kind of doing the same thing where we're solving trig equations and solving trig equations by factoring. So now we're going to use our identities. Um, I recommend you having this formula chart open, whether you have the paper version or you're using the Schoology version. I highly recommend you having this because these are the identities we're going to be using, right? Tangent is sine over cosine. Cotangent is cosine over sine. We're going to be using reciprocals and also the Pythagorean identities, all right? So let's do some examples. So what I'm going to do in this first part is I'm going to go over the left side, and then I'm going to make another version where I'm going to go over the right side, and these are just going to be extra examples. All right, so let's look at number one. So number one, we have square root of 3 tangent x equals 2 sine of x. Usually what happens here is I have a tangent and a sine, and if I subtract it, they still won't have a common factor. So what I'm going to do is I'm going to change this tangent to sine over cosine, right? Tangent is sine over cosine. So let's write this as the square root of 3 of sine of x over cosine of x equals 2 sine of x. All right. And so what's going to happen here is we don't want fractions. So what I'm going to do is I'm going to multiply both sides by the cosine of x. That way I get rid of that denominator. And so what we're going to be left with is the square root of 3 sine of x equals 2 sine of x times cosine of x. All right, and so now what we have is a sine of x on both sides, right? And so what we want to do is we want to move everything to one side and be able to factor out that sine of x. Okay, so I'm going to subtract. You can subtract whichever you prefer. Let's just subtract 2 sine of x from both sides. So we're going to have the square root of 3 sine of x minus 2 sine of x times cosine of x, and that is all going to equal 0. All right, so now we're going to be able to use the zero product property because we're going to factor out here a sine of x because they both have sine of x in common. That's our GCF. Okay. All right, so don't forget to write out the sine of x up at the front. That's another factor. And so here we're going to have the square root of 3. These are going to divide out, minus 2. These also divide out, cosine of x equals 0. Now remember, because of the zero product property, we set both of these equal to 0. So sine of x equals 0, and then the square root of 3 minus 2 cosine of x equals 0. All right, and so here we're going to solve for cosine of x. So I'm actually just going to add 2 cosine of x to both sides. So square root of 3 equals 2 cosine of x. And then we're going to divide by 2. And so cosine of x is equal to the square root of 3 over 2. So now we have two equations we want to solve, right? We're going to solve cosine of x equals the square root of 3 over 2, and we have to solve for when sine of x is equal to 0. All right, and this is over the interval from 0 to 2 pi. That's for all of the problems. It's 0 to 2 pi, so just make sure you're paying attention to that. So let's solve these. So for sine of x equal to 0, remember sine of x is horizontal, so we're going to be at the angles 0, pi, and 2 pi. Don't forget about 2 pi. Okay, and then for cosine of x equals to square root of 3 over 2, remember cosine of x is vertical, straight up and down, so they're going to be right on top of each other. And that's going to happen at pi over 6 and 11 pi over 6. Okay, now remember there's two different ways you can write this. For a free response question, you can put them in whichever order. So 0, pi, 2 pi, pi over 6, and 11 pi over 6. But for multiple choice, it will be in numerical order. Okay, so just make sure you're aware of that. It's going to be 0, pi over 6, pi, 11 pi over 6, and then 2 pi. I highly recommend doing this just because, like not always, but whenever you get the chance and you have quite a bit of solutions, I would try to put them in order just so you can practice that habit. That way, once you see multiple choice, oh, you'll know what the order is for all of our fractions. All right, let's look at number 3. Okay, so number 3, we have a rational expression, right? We have a fraction. So just remember that 1 minus sine of x cannot equal 0, right? Because then it would be undefined, right? Or basically, we don't want sine of x to equal 1. Okay, so just be aware of that. Okay, now what we're going to do is we're going to multiply both sides by 1 minus sine of x. That way we can get rid of that fraction. So cosine of x times cotangent of x equals 3 times 1 minus sine of x. So here what we could do is distribute this 3 on this side. And then here, the cotangent, I'm going to rewrite that as cosine over sine. Remember, cotangent is cosine over sine. Okay, so cosine x times cosine x over sine x equals 3 minus 3 sine of x. All right, so again, we do want to get rid of this denominator again. So what we're going to do is we're going to multiply both sides by sine of x to cancel out that denominator. That's going to be a big theme in today's lesson, is trying to get rid of the fractions. Okay, so, and here we have cosine times cosine, so I can rewrite that as cosine squared of x equals, and then I'm going to go ahead and distribute this sine. So this is going to be 3 sine of x minus 3 sine squared of x. Okay. All right, so now if you notice, we have cosine squared x here and 3 sine x and 3 sine squared x. So we really don't have one trig function, we have two. But if we think about it, and if you remember, we can rewrite this as 1 minus sine squared theta, or whatever the angle variable is. Right, so I'm going to change that cosine squared theta to 1 minus sine squared theta. So this is going to be 1, or x. 1 minus sine squared x equals 3 sine of x minus 3 sine squared x. Okay, so this is a Pythagorean identity right here. Okay, and then next up, what I'm going to do is I'm going to move everything to one side. So I'm going to add this 3 sine squared x to the -1 sine squared x. And then I'm also going to subtract the 3 sine x. So basically moving everything to one side. Okay, and so what we're going to end up with is 3 minus 1 would be 2 sine squared x minus 3 sine x plus 1 equals 0. All right, and so this is our quadratics, right? We have sine squared x, sine x. So what I'm going to do is, I don't like doing this with sine of x, so I'm just going to rewrite sine of x as u, a different variable. So we're going to have 2u squared minus 3u plus 1, right? And if we factor, so we need two factors. Remember, you multiplied 2 times 1, so that's 2. I forgot to set this equal to 0. And then I need two factors of 2 that add up to 3, negative 3. So that would be negative 2 and negative 1, right? So I'm going to rewrite this as 2u squared minus 2u minus 1u plus 1. And then I'm going to factor this by grouping. So I'll take out a 2u, that's going to be u minus 1. And take out a negative 1, that'd be u minus 1. And so this is going to factor out to be 2u minus 1 times u minus 1. Right? And then we just replace, or actually what I'm going to do is I'm going to set u equal to positive 1/2 and u equal to 1. And now we can replace u with sine of x. I'm going to do that right here. So I want sine of x to equal 1/2 and sine of x to equal 1. Okay. Now sine of x equals to positive 1/2. That, remember, that happens at pi over 6 and 5 pi over 6. And sine of x equals to 1. Well, if you remember, sine of x cannot equal to 1 because that's going to give me an undefined value. So that is not going to be one of our solutions. Whatever the sine of x equals to 1 would be at x equals pi over 2. But since we do not want sine of x equal to 1, then the only answers are pi over 6 and 5 pi over 6. Okay, so just make sure you're careful with that. Sine of x is undefined, or 1 minus sine of x would make the value undefined. All right, let's go to the next one. All right, number 5. So here we have tangent squared of x equals 2 tangent of x times sine of x. All right, so here what we're going to do is they both have a tangent in common, so I'm going to be able to subtract 2 tangent of x sine of x to both sides, or subtract it from both sides. So we're going to end up with tangent squared x minus 2 tangent of x sine of x equals 0. They both have tangent in common, so I can factor out a tangent. So that would be tangent of x minus 2 sine of x. And that's going to equal 0. So we want tangent of x to equal 0. And then tangent x minus 2 sine of x to equal 0. All right. And then what we're going to do here is we're going to repeat the process of using trig identities. So here I'm going to change this to sine of x over cosine of x minus 2 sine of x equals 0. And now what we're going to do is we're going to get rid of that fraction, we're going to multiply both sides by cosine of x. Now this is going to distribute, and what's going to happen here is this is going to cancel out. So we're going to be left with sine of x minus 2 sine of x times cosine of x. Because we distribute that cosine, we have to multiply the entire side of the equation. And then 0 times cosine of x is just 0. All right, and then now they both have a sign in common, so I can factor out a sign. So this is going to be 1 minus 2 cosine of x equals 0. We set both of these equal to 0, so sine of x equals 0. And then 1 minus 2 cosine of x equals 0. Once we solve this for cosine of x, we would get positive 1/2. And so now we have three equations we need to solve, right? So cosine of x equals 1/2, sine of x equals 0, and tangent of x equals 0. Now, tangent of x equals 0, technically this is 0 over 1. So we want our y value to be 0 and our x value to be 1, right? So that's going to happen at 0, pi, and 2 pi. Right, I forgot, this is plus or minus, right? 0 divided by positive 1 or 0 divided by negative 1, because they would both be 0. And then sine of x to equal 0, so that's our y value to equal 0. So again, that's 0, pi, and 2 pi. And then finally, we want x to equal 1/2. All right, and that's going to happen at x equals pi over 3, and then all the way down to quadrant 4, which is 5 pi over 3. All right, so my answers are 0, pi over 3, pi, 5 pi over 3, and 2 pi. All right, let's do the last one. Number 7. So we have 2 tangent squared of x equals 3 secant x. Whenever you see tangent squared or anything squared, and on the other side they have the other value that's in the Pythagorean identity, like here tangent squared is equal to secant squared x, then you know that you have to just change that tangent squared to secant squared minus 1. So this we're going to change it to secant squared of x minus 1 equals 3 secant x. Now the reason I put it in parentheses is because we're going to have to distribute that 2. So this 2, we're going to distribute it to both terms. So this is going to be 2 secant squared of x. I'm going to go ahead and subtract this from the other side. So 3 secant x, and then minus 2 equals 0. All right, so this is a quadratic, right? So secant x, I can write that as u for u substitution. So 2u squared minus 3u minus 2 equals 0. So we're going to be factoring. So 2 times negative 2 is negative 4. So I need two factors of negative 4 that add up to negative 3. Right? And that's going to be negative 4 and positive 1. Negative 4 times 1 is negative 4. Negative 4 plus 1 is negative 3. So we're going to rewrite this negative 3u squared as 2u squared minus 4u plus u minus 2 equals 0. I can divide out a 2u. So 2u would be u squared minus 2. No, not u squared, but u squared. Just u, sorry. U minus 2. And then here, technically, we're just factoring out a 1, so we don't change it because we want it the same as this. So u minus 2. And then we factor the u minus 2 out, equals 2u plus 1 equals 0. Right, and then I can set both of these equal to 0, so u minus 2 equals 0, and 2u plus 1 equals 0. So here u would equal 2, because I would add 2 to the other side. Here u would equal negative 1/2, right? Because we would subtract 1 and then divide by 2. All right, and then we can replace u with secant. So secant of x equals 2, and then secant of x equals negative 1/2. All right, now secant is the reciprocal of cosine, right? So that means cosine of x is equal to 1/2, and then cosine of x is equal to the reciprocal of 1/2 would be negative 2. All right. Now, cosine of x is never equal to negative 2. Remember, cosine is just from negative 1 to 1. So all we have to worry about is when cosine of x is equal to 1/2, and that happens at pi over 3 and 5 pi over 3. So my answer would just be pi over 3 and 5 pi over 3. All right, let me know if you have any questions.